Have you ever pondered about the concept of incompleteness in mathematics and philosophy? Does it intrigue you or perhaps leave you baffled? Imagine a puzzle, a vast, intricate puzzle that represents the entire realm of mathematical truth. Now, what if we told you that this puzzle, no matter how meticulously we try to solve it, will always have missing pieces? That's the crux of the concept of incompleteness, a profound idea that has left an indelible mark on the foundations of mathematics and philosophy. This intriguing concept was introduced by the renowned mathematician and logician Kurt Gödel in the early 20th century. Gödel's incompleteness theorems fundamentally altered our understanding of formal mathematical systems, revealing inherent limitations and challenges that were previously overlooked. What Gödel essentially stated was that within any consistent and formal mathematical system, there exist true statements that cannot be proven within the system itself. In simpler terms, even the most elaborate and powerful mathematical system will always have truths that it cannot capture. It's like trying to map an endless terrain using a finite set of tools. Gödel achieved this by constructing a self-referential statement or a Gödel sentence, which in layman's terms states, "This statement is unprovable within the system." A paradox, right? If the statement were provable, it would contradict itself. If it were unprovable, it would validate its claim, thus demonstrating the existence of true but unprovable statements. This revelation shook the foundational belief in the completeness and self-sufficiency of formal mathematical systems. It was a groundbreaking moment, a moment that reminded us of the inherent limitations within formal systems, regardless of their complexity. But why does this matter? Well, the concept of incompleteness has far-reaching implications, not just in mathematics, but also in the philosophy of mind, the nature of knowledge, and even fields like computer science and artificial intelligence. This notion of incompleteness, as we will see, has far-reaching implications that extend beyond the realm of numbers and equations. It serves as both a humbling acknowledgement of our cognitive boundaries and an invitation to explore the profound mysteries that lie beyond them. So, let's delve deeper into this concept. What exactly does Gödel's incompleteness theorem state? Imagine we have an elaborate, meticulously designed mathematical system. It's consistent, which means it doesn't contradict itself, and it's formal, meaning it strictly follows a set of established rules. Now, Gödel's incompleteness theorems come along and say, hold on a minute, there's something you can't do. These theorems assert that within this system, there exist true statements that cannot be proven using the system's own rules. To put it simply, there are truths that this mathematical system, no matter how comprehensive it seems, can't reach. To illustrate this, Gödel created what we now call the Gödel Sentence. This sentence is a bit of a cheeky paradox. It says, this statement is unprovable within the system. If we could prove this sentence within the system, it would be contradicting itself, leading us into a logical paradox. But if the sentence is indeed unprovable, it's doing exactly what it said it would, making it a true statement that the system can't prove. This is where the ground beneath us starts to shake. It's a revelation that disrupts the belief in the completeness and self-sufficiency of formal mathematical systems. No matter how expansive or powerful a mathematical system may be, Gödel showed us that it cannot capture all mathematical truths. There will always be truths that sit just out of reach, beyond the system's grasp. But what does this mean for us? Well, it throws open the doors to a world of questions about the nature of truth, knowledge, and the inner workings of human thought. It forces us to acknowledge that there are limits to what we can achieve through formal systems, but it also invites us to explore the mysteries that lie beyond these boundaries. In essence, Gödel's work underlines the inherent limitations of formal mathematical systems and the existence of truths that lie beyond their reach. Now, how did Gödel arrive at this groundbreaking conclusion? The answer lies in the Gödel Sentence. This sentence, ingeniously crafted by Gödel himself, is a self-referential statement that essentially says, this statement is unprovable within the system. The Gödel Sentence is a paradoxical marvel of mathematics. It's a statement that refers to its own truth, yet it declares itself unprovable within its own mathematical system. It's a bit like a serpent biting its own tail, a self-contained paradox that both challenges and validates itself. The brilliance of the Gödel sentence lies in its simplicity. The sentence doesn't depend on complex mathematical equations or convoluted logic. Rather, it's a statement that's both profound and self-evident. It embodies the essence of Gödel's incompleteness theorems, demonstrating the inherent limitations of formal mathematical systems. Let's break it down. If the Gödel sentence is provable within the system, then it contradicts itself because it's claiming to be unprovable. This contradiction results in a paradox. On the other hand, if the Gödel sentence is indeed unprovable, then it validates its own claim, proving the existence of true but unprovable statements within the system. This paradoxical nature of the Gödel sentence supports the core argument of the incompleteness theorems. It shows us that there are true statements that cannot be proven within their own mathematical systems. This is a profound revelation, shaking the foundational belief in the completeness and self-sufficiency of formal mathematical systems. The Gödel sentence, in its simple yet profound self-reference, encapsulates the inherent limitations of formal logic and arithmetic. It gives us a glimpse into the vast and uncharted territories of mathematical truth that lie beyond the reach of our formal systems. So, Gödel's cleverly crafted sentence not only demonstrates the concept of incompleteness, but also provides a tangible example of it. It's a testament to the genius of Kurt Gödel, illuminating the inherent boundaries of formal systems. The Gödel sentence, in its elegant simplicity, encapsulates the paradox that underpins the concept of incompleteness. It serves as a stark reminder of the limitations of our own cognitive capacities, and of the profound mysteries that lie beyond the boundaries of formal logic and arithmetic. Gödel's incompleteness theorems have had a profound impact on various fields, but what are these implications exactly? For instance, consider computer science. Gödel's theorems have informed the development of algorithms and computational theory. They've reminded us that no matter how sophisticated a program or system might be, there will always be problems that it cannot solve. This humbling realization has driven the quest for new computational paradigms and approaches. Now, think about artificial intelligence. The recognition of inherent limitations in formal systems has led to a deeper understanding of the complexity and richness of human cognition. It has posed profound questions about the boundary of what artificial intelligence can achieve and the nature of intelligence itself. Then there's cognitive science, a field that explores the workings of the human mind. Gödel's theorems have fueled discussions about the nature of human thought. They've prompted us to consider whether our brains operate like formal systems, and if so, are they subject to the same limitations? Are there truths that we can intuit but not prove? Moreover, Gödel's work has had philosophical implications related to the nature of truth and knowledge. It's challenged the belief in the completeness and self-sufficiency of formal mathematical systems. It suggested that there are truths that exist outside the confines of formal logic and arithmetic, truths that might be apprehended through intuition or other non-formal means. In essence, Gödel's theorems have pushed us to grapple with the boundaries of formalized structures. They've reminded us that there are limits to what can be achieved through formal systems. They've underscored the existence of truths that lie beyond the reach of formal logic, prompting us to explore new ways of understanding and expressing reality. Incompleteness, as articulated by Gödel, not only reshaped our understanding of mathematics, but also posed profound questions about the nature of human cognition and the limits of formalized structures. Incompleteness as a concept continues to resonate in our pursuit of knowledge and understanding. The brilliance of Kurt Gödel's incompleteness theorems has left a lasting imprint that transcends the realm of mathematics and philosophy. Let's take a moment to reflect on the key points we've discussed. Gödel's groundbreaking work revealed the inherent limitations of formal mathematical systems. He showed us that no matter how elaborate or powerful a mathematical system might be, it cannot capture all mathematical truths. This was encapsulated in the Gödel sentence, a self-referential statement that demonstrated the existence of true but unprovable statements. This profound realization shook the very foundations of our belief in the completeness and self-sufficiency of formal mathematical systems. But it didn't stop there. The implications of Gödel's theorems reverberate beyond the boundaries of mathematics, influencing fields as diverse as computer science, artificial intelligence, and cognitive science. The recognition of inherent limitations in formal systems has deepened our understanding of the complexity and richness of human cognition. It has posed profound questions about the nature of truth and the boundaries of what can be known and expressed through formalized structures. The legacy of Gödel's incompleteness theorems is one of enduring relevance. In an age of rapid technological advancement and artificial intelligence, the concept of incompleteness continues to shape our understanding of the world and our place within it. As we strive to unravel the mysteries of the universe, Gödel's work serves as a stark reminder that there are truths that lie beyond the reach of our formal systems, beyond the grasp of our logic and arithmetic. Yet it's not a cause for despair, but rather an invitation, a challenge even, to push the boundaries of our understanding, to question, to explore, and to seek out those profound mysteries that lie beyond the confines of formal systems. Incompleteness serves as both a humbling reminder of our cognitive boundaries and a tantalizing invitation to explore the profound mysteries that lie beyond the confines of formal systems.